Hello my friends, today we are going to learn on how to solve, how to find the transfer function given a block diagram. Then we are taught to reduce it to a single block diagram or convert it to single flow graphs. So we have a question from 2023 number 9 in electrical and electronics engineering. We were taught to draw a signal flow graph for equivalent block diagram. So, first to draw the signal block diagram, the summary point and takeoff point changes to be a node. Now, this is how we go about it. So, TF is given by, in Maxwell's gain formula, is given by TK delta K divided by delta, where K is a forward, represent the forward path, TK, not T but TK, represent forward path, delta K is given by 1 minus any loop which is not touching the forward path, minus the loop which is not touching the K path. So in our flow graph here, we have only forward path, only one forward path, which is T1, given by T1 given by G1, G2, G3, and G4. This is only forward path that we have in this signal flow graph. Then delta in K path is 1 because all the loops are touching the forward path. So we don't have a loop which is not touching the forward path, so we have 0. So our delta K gives us 1. So such that Tk times delta K is equals to the value of the forward path. Now, first to get delta in denominator is 1 minus loop 1 plus loop 2 plus possible loop 3, then plus any combination of two non-touching loops, let's say L1, L2, then minus any combination of 3 non-touching loops, let's say L1, L2, L3, is how we get the delta in the denominator. But in this case, loop 1 is given by G1, G2, then back to the node S1. Starting from node S1 to take off point T1, then back to S1. That is what we call about the loop. So we call the loop. So L1 is given by G1, G2, then times minus H1, negative H1, which gives us negative G1, G2, H1. Then L2, and say L2 is from S3 to T3, then back to S3. So is G3, G4, then times negative H2, which gives us minus G3, G4, H2. Our L3 is given by L3 is from S2 to T2, then back to S2. So we have G2, G3 times negative H3, which gives us negative, which which in our transfer function, we have Tk, which is T1, divided by times delta 1 divided by the delta in the denominator. So now this gives us T1 is given by G1, G2, G3, G4 divided by our delta, which is 1 minus in brackets L1, which gives us minus negative G2, G1, G2, then H1 plus minus G3, G4, H2 plus minus G2, G3, H3, then plus our possible combination of two non-negatives. We have L1 and L3. L1 and L2, they are non-touching. L1 and L2, they are non-touching. So we have combination of the against. L1, which is negative G1, G2, H1. Now we multiply with negative G3, G4, H2. So let's work on this. So this gives us G1, G2, G3, G4 all over all over 1 plus G1, G2, H1 plus G3, G4, H2 plus G3, G2, G3, H2. Then plus negative times negative, we get positive. Then plus G1, G2, G3, G4, H1, H2. Now, if we factor out the common factor, G3, G4, G3, G4. So we'll have G1, G2, G3, G4 divided by 1 plus G1, G2, H1 plus G2, G3, H2 plus H3, not H2, H3 plus G1, G2 plus not G1, G2 but G3, G4, H2. In these two terms we have G3, G4, H2, G3, G4, H2, so we can factor out G1, G4, H2. So that we have to get 1 plus